Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Putri Nordana binti Ramli and my metric number is F1075. So now I will explain about soil consolidation. So soil consolidation is the gradual reduction in volume of saturate soil due to the explosion of pore water when a load is applied. This commonly occurs in clay soils because of their low permeability. When structures such as building or road are placed on the ground, the pressure causes water to be squeezed out, making the soil more compact. Next, the basic principle is based on the effective stress concept, where total stress is equal to effective stress plus pore water pressure. Initially, the load is carried by water. So next, the consolidation process occurs in three stages. So first, initial compression or immediate settlement. So second, primary consolidation, which involves water drain. And third, secondary consolidation, which is the slow movement or creep of soil particles. So now I will explain the construction process of the consolidation on site. So this process involves several important steps to ensure the soil becomes denser and more stable before construction begins. So the first step is site preparation, which includes clearing and preparing the ground. The second step is load placement, such as adding fill material to accelerate consolidation. So next, vertical drains are installed to allow pore water to escape more quickly. Then, consolidation occurs as water is gradually expelled due to the applied load. Finally, monitoring is carried out to ensure settlement and soil stability are within safe limits. This process is important as it helps reduce excessive settlement after construction is complete.
My name is Nur Edina Zulaika binti Zainuddin and my matrix number is F1062 and I will be continuing the presentation with 3.0, which is terms used in consolidation activities. First, the terms that used in consolidation activities is volume compressibility, which is MV. Volume compressibility is a work that needs to measure how much soil compresses under pressure. And the formula of volume compressibility is mv equals to delta E over 1 plus E times delta sigma. As shown in the slide, example calculation, given initial void ratio E0 equals to 0.80 and change in void ratio delta E equals to 0.10 and the change in effective stress, which the symbol is delta sigma, equals to 100 kilonewton over m squared. And all the data given are applied and substitute in the formula, and we got the final answer, which is the MV is 0.00056 kilonewton over m squared, which make if the MV value are higher, the more settlements it needs. Number 2, coefficient of consolidation, which is CV. Coefficient of consolidation is a rate at which consolidation occurs, and it depends on permeability and compressibility. First, permeability. What is permeability? Permeability is the ability of a material like rock, soil, or membrane to allow liquids or gases to pass through it, determined by the size and interconnection of its pores. Number 3 is the degree of consolidation, which is U. Degree of consolidation, U, is the percentage of total settlement that has already occurred at a given time, which make the percentage of consolidation completed. Range of the degree of consolidation is 0 to 100%. And based on the settlement, the formula is U equals to ST over SF. What is ST? ST is settlement at time and SF is final settlement. The example that I gave in the slide is settlement at time given 20 millimeter, and final settlement is 40 millimeter, which all the data are applied and substitute in the formula, which we get 50%. That means 50% or halfway of the working, which means half of settlement has happened. If the U value is 100%, that means the apologize me. If the U degree is 100%, that's mean the consolidation work is fully completed. Now let's move on to number 4, which is time factor (TV). TV is used to calculate time for consolidation, which means if we want to calculate the time for the consolidation, how much time it takes to do the consolidation work, and then it helps us to determine how fast consolidation happens over time, like I just said just now, and it related to CV and drainage path. The higher the CV value is, the faster the consolidation works are. And number 5, which is the last one, is rate of settlement. Rate of settlement, which means speed at which soil settles over time. And it's also the rate of settlement is also important for construction planning.
Assalamualaikum. My name is Nur Atira Najwa binti Rusman. My matric number is F1054. Now I want to continue about a problem related to consolidations. The first is excessive settlement. Excessive soil settlement can cause structural damage, such as crack and tilting of buildings. The second is differential settlement. Uneven settlement between part of a structure create unequal stress and can lead to structural failure. The third is long time first settlement. Clay soil take a long time to consolidate, so settlement occurs slowly over a long period. Next is stability issues. Soft soil have low strength and may fail when subjected has heavy loads. The lastly is construction delays. Construction project may be delayed because time is needed for the soil to stabilize before continue work. In conclusion is soil consolidation is an important concept in soil mechanics that explains the gradual settlement of soil due to the expulsion of water from its pores when subjected to loads. This process mainly occurs in saturated clay soils and takes place over a period of time. Understanding the principle of consolidations such as compressibility, coefficient of consolidations, and degree of consolidations. Its essence is predicting settlement behavior in engineering projects. In constructions, proper analysis to consolidations helps engineering to prevent problems such as excessive settlement, cracking, and structural failure. Therefore, knowledge of consolidations is crucial in the design of foundations, embankment, and other geotechnical structure to ensure safety, stability, and long-term performance. That's all for us. Thank you.